Good afternoon. This is Jeff Perlman, founder and CEO of Xojo, and welcome to this webinar on the magic of auto layout and constraints for iOS projects. I'm here with Greg Alone. He's going to be presenting today. And if you have any questions, put them in the Q&A panel, and we'll get to them at the end of the presentation. So without further ado, take it away, Greg.
Hey, everybody. So for those of you who don't know me, I worked as a software engineer at Xojo from February 2011 to February 2022 on several different aspects of Xojo, including Web 1, Web 2, the IDE, Xojo Cloud, feedback, DevOps, fixing bugs in macOS and the iOS frameworks, and several other internal projects, including the XDC web and iOS projects. Before working for Xojo, I had used Xojo and Real Studio for 10 years in my own company, writing business intelligence software for companies in Jacksonville, Florida. So today, we're going to take a deep dive into what auto layout is and how it works. Then we're going to look at the Xojo implementation of constraints and talk about some issues that were caused by their simplification of constraints. Next, we'll talk about what improvements Apple made later to make auto layout easier. And then we're going to wrap up with what Xojo developers can do to get the best experience possible. So first of all, what is auto layout? Auto layout is math. More specifically, auto layout dynamically calculates the size and position of all the views and controls in your view hierarchy based on mathematical constraints placed on those items. For example, you can constrain a button so that it is horizontally centered with an image view, and so that the button's top edge always remains 8 points below the image's bottom. If the image's size or position changes, the button's position will change automatically. This constraint-based approach to design allows you to build user interfaces that dynamically respond to both internal and external changes. But what are internal and external changes? Well, external changes are things that are outside of your app's control. Things like resizes on macOS, changes to a split view on an iPad, device rotation on iOS, active call and audio recording bars appearing and disappearing, or just displaying your app on a different device with different screen sizes. Internal changes are when your app's content changes. The new content may require a different layout than the old. This commonly occurs when the apps display text or images. For example, a news app needs to adjust its layout based on the size of individual news articles. Similarly, a photo collage must handle a wide range of image sizes and aspect ratios. Localization, of course, is the process of making your app able to adapt to different languages. Localization has three main effects on layout. First, when you translate your user interface into a different language, the labels require a different amount of space. German, for example, typically requires considerably more space than English, while Japanese frequently requires less. Second, the format used to represent dates and numbers can change from region to region. Even if the language does not change, although these changes are typically more subtle than language changes, the user interface still needs to adapt to the slight variation in size. Third, changing the language can affect not just the size of the text, but the organization of the layout. Different languages use different layout directions. English uses a left to right layout direction, but languages like Arabic and Hebrew use a right to left language direction. In general, the order of the user interface elements should match the layout direction. If a button is on the bottom right corner of the view in English, it generally should be on the bottom left in Arabic. Finally, if your app supports dynamic type, the user can change the font size in your app. This can change both the height and the width of any textual elements in your user interface. If the user changes the font size while your app is running, both the fonts and the layout will need to adapt. So there's three main approaches to laying out a user interface. First, you can programmatically lay out the user interface. You can also use auto resizing masks to automate some of the responses to external change, or you can use auto layout. Traditionally, before the dawn of IDEs or layout editors like Xojo, apps laid out their user interface programmatically, setting the frame for each view in a view hierarchy in code. The frame defined the view origin, height, and width in the superview's coordinate system. To lay out your user interface, you had to calculate the size and position for every view in your hierarchy. Then, if a change occurred, you had to recalculate the frame for all the affected views. It's very powerful, but very time-consuming. You can use auto resizing masks to help alleviate some of the effort by defining how an item's frame changes when the containing item's frame changes. This greatly simplifies the creation and maintenance of layouts that need to adapt to external changes. This method supports a relatively small subset of possible layouts. For complex layouts, you typically need to augment with your own programmatic changes. Additionally, it only adapts to external changes. But this is what Xojo does on desktop, web, and Android in a visual way through its layout editor. Auto layout defines your user interface using a series of constraints. Constraints typically represent the relationship between two views or controls. Auto layout then calculates the size and location of each view based on the constraints. This produces layouts that can dynamically respond to both internal and external changes. So what are constraints? Let's use this typical situation as an example. What we want here is for the text field on the right to always be 8 points from the label that's on the left. The description of the constraint looks like this. Cityfield.left equals 1 times citylabel.right plus 8. Here are the auto layout names for each of the components. You've got an item with an attribute, the relationship between the two, a multiplier, second item, second attribute, and a constant. The wide range of parameters and attributes available to these equations lets you create many different types of constraints. You can define the space between the views, align the edges of views, define the relative size of two views, or even define a view's aspect ratio. However, not all attributes are compatible with each other. Attributes fall into three categories: horizontal, horizontal, vertical, and dimensional. In general, horizontal attributes need to be constrained against other horizontal attributes, as with vertical and dimensional. One exception to this rule is that left and right cannot be used with leading and trailing, and you need to use one or the other. Horizontal and vertical attributes allow you to specify location, whereas dimensional attributes denote size. So there are some basic rules for constraints. You cannot constrain a size attribute to a location attribute. Width cannot be constrained to left, for instance. You cannot assign a constant value to location attributes without additional relationship information. But it's perfectly fine to set a size attribute to a certain value. So you can set width to 40. You just can't say left equals 40 without saying this is what it's measured against. You cannot use a multiplier other than 1 with location attributes. You can't constrain vertical location attributes to horizontal location attributes. Left to top is not allowed, for instance. You cannot constrain leading or trailing attributes to left or right, as I mentioned earlier. And when working with equality constraints, you always need two constraints per dimension, left and width, or left and right, for instance. I've mentioned in the last two slides, and I thought I mentioned in the last two slides, left and leading and right and trailing, and I wanted to talk about that for a moment. Left and right are absolute. That is, they always represent the left and right edges of a view or control. Leading and trailing are relative. For left to right languages, they represent left and right. For right to left languages, they're inverted, such that leading equals right and trailing equals left. The reason that there are two is that even if the end user is using a right to left language, you still have elements that sometimes need to be positioned relative to the left or right edge of a view. Here are some common examples of constraints. For instance, setting a constant height of 40, or setting a fixed distance between two buttons, aligning a leading edge, making two buttons that have the same width, centering a view in its superview. And one time when a multiplier is not equal to 1 is allowed is when setting an aspect ratio for a view. So far, all the examples I've shown have constraints as equalities, but this is only part of the story. Constraints can also represent inequalities. Specifically, the constraints relationship can be equal to, greater than or equal to, or less than or equal to. Here's the equality from the previous slide. And here's an inequality that sets the two buttons to stay between 8 and 40 points from one another. As soon as you start using inequalities, the two constraints per view per dimension rule breaks down. You can always replace a single equality relationship with two inequalities. So in this case, you could have the leading, two things for the leading and a width, as opposed to just left and width. By default, all constraints are required, and auto layout must calculate a solution that satisfies all of the constraints you've provided. If it can't, there's an error. In that case, auto layout prints the information about the unsatisfiable constraints to the console. It chooses one or more of the constraints to break and recalculates without the broken constraints. You can, however, create optional constraints. When calculating layouts, auto layout attempts to satisfy all the constraints in priority order from the highest to the lowest. If it can't satisfy an optional constraint, it's skipped. But if this results in an ambiguous layout, that is, there's more than one solution, the system will select a solution that comes closest to the constraint. That means that even if an unsatisfied optional constraint exists, it may still have influence on your layout. Optional constraints and inequalities often work together. Using the previous example, the first constraint requires that the buttons be at least 8 units away from each other. Depending on the other constraints in the layout, the second one will try to keep them at most 48 points apart. So far, we've been talking about items and controls which have a fixed size. Some views have a natural size given their current content. This is referred to as intrinsic content size. Here are some examples. UI view, which represents just about everything in an iOS layout, does not have an intrinsic content size by default. Sliders, however, have intrinsic width, but not height. Labels, buttons, switches, and text fields define both width and height. And text areas and images vary depending on their contents. Auto layout represents an item's intrinsic content size using a pair of constraints for each dimension. Compression resistance pushes the edges outward so that the content is not clipped. Content hugging pulls the edges inward so that it fits snugly around the content. By default, content hugging has a priority of 250, and compression resistance has a priority of 750. This means that it's easier to stretch a view than it is to shrink it. For example, you can safely stretch a button to be larger than its intrinsic size without whereas shrinking it might cause the content to be clipped. Oh, that's a lot of information. So let's talk about constraints in iOS projects, Xojo iOS projects. First of all, we need to remember that Xojo's iOS layout system was designed in the spring of 2013, and the Xojo iOS framework was released in December 2014. Apple released Swift 1 in the fall of 2014. Just like Apple, Xojo's iOS layout constraint constructor takes the following parameters: 2 items, 2 attributes, a relationship, a multiplier, a constant, and a priority. In an attempt to make auto layout more Xojo-ish, it was decided that the constraint system that Apple provided needed to be simplified. Priority was made read-only, which means that if you need to change a priority, you need to destroy a constraint and recreate it from scratch. That's because in the underlying NS layout constraint, you cannot change a priority when you're going to or from required. Xojo also attempted to simplify the names of the parts of the constraints, so you'll need to remember that the names are similar, but not exactly the same. Xojo also assumes that the screen margins match the safe area, which was true in 2014. Unfortunately, this makes it impossible to easily avoid physical traits like the notch that appeared on the iPhone 10 and the new dynamic island that was introduced on the iPhone 14 Pros. And unfortunately, the Xojo layout editor sometimes does not match the runtime behavior because the Xojo IDE has its own constraint solver, but iOS assumes that the information being passed to it match Apple's guidelines 100%. So here are the Apple-defined constants for constraint priorities. Xojo added an arbitrary medium-high priority and redistributed the values evenly. And because the Xojo framework ignores the existence of content hugging and compression resistance, it causes 2 weird inflection points where hugging and compression occur. By default, compression resistance restrictions get disabled between Xojo's low and medium, which means things can start getting smaller. And content hugging is disabled when between Xojo's medium, high, and high priorities, allowing things to grow if necessary. Additionally, the underlying Apple framework allows you to change the compression resistance and content hugging values per layout. There are a number of best practices you can follow to work around the limitations in the odd behavior of the Xojo IDE. First, you can draw a diagram. Use paper, a drawing program, something other than Xojo to lay out what you want your layout to look like. Second, always work in the same direction. If at all possible, constrain only to items that are above and to the left of the item you're working on so that the offsets are always positive. And don't create duplicates. Button 2.left to button 1.right and button 1 right to button 2 left are the same thing. You don't need both, and it'll be very confusing to resolve later. Don't use priorities lower than 251. At that level, iOS starts eliminating constraints to make controls smaller if necessary. If you don't want iOS making things bigger, You need to stay above 750. Fix constraint errors as soon as possible. When creating a layout, if things move or resize oddly, look at the constraints and fix them right away. If you're changing an existing layout, adjust the constraints directly. Dragging controls on the layout editor may cause the IDE to rewrite one or more other constraints. And if all else fails, write your constraints in code. Now, as I said earlier, just before the Xojo framework was released, Apple released Swift 1, and they actually started trying to make auto layout easier to use. Unfortunately, Xojo's iOS layout system was done, and changing it would have set us back by months and possibly years. With the release of the Swift language, Apple came up with a way to create easier to read constraint code. Let's take our example from earlier. The new mechanism using anchors looks something like this. There's a lot more text, but it's a lot more exact representation of what's going to happen. Starting at city field's leading anchor, you make a constraint that's equal to the system spacing after city label's trailing anchor and set its active property to true. In addition, anchors make it easier to reference layout margins, safe areas, and readable content areas. Layout margins include predefined guides that make it easy to apply standard margins around content. Safe areas define the area within a view that's not covered by a navigation bar, a tab bar, a toolbar, or any physical features of a device like the dynamic island or the notch. Readable content areas represent an area that can easily be read without forcing users to move their head to track the lines. So where does that leave Xojo developers? Well, in case you're wondering, it is possible to fix all these problems in your projects. It does involve writing many of your constraints in code, but the results are much more predictable than you can get by using just the Xojo layout editor. If you want even more control, you'll need to use declares or a third-party library. Now, writing constraints in code isn't terrible. Knowing what we've learned earlier about priorities, we can steer clear of the hugging and compression stuff by just keeping the priorities higher than 750. So you could just add a constraint that tells a text field to be 8 points from the neighboring label like this. Text field 1, leading edge, is equal to label 1's trailing edge plus 8 points. However, control that's already on the layout already has a required constraint for its position. So you either need to remove them or set their priority to something lower in the IDE to make it work. Removing a constraint in code involves naming the constraint at design time and then asking the layout for that constraint and deactivating it at runtime. Now, if you're feeling more ambitious, you could write declares for managing constraints. They're all just NS layout constraints under the hood, and by referencing controls using their handles, you can do anything someone using Objective-C and Swift can do. The third party has created some very extensive libraries for dealing with the limitations of Xojo iOS projects, and we're lucky that they've been willing to maintain their libraries for as long as they have, because they cover many of the things that the base framework does not have. Unfortunately, I was unable to find a library for constraints, so I made one. It's an extensive library which has support for making NS layout constraints by hand, as well as the newer anchors. To be specific, my library contains full NS layout constraint support with hugging and compression, Apple and Xojo priority constants, NS anchor support, and UI stack view. It also includes an extensive library of 40 method extensions for mobile screen and mobile UI control, to expose most of Apple's constraint framework to Xojo users and a simple animation mechanism that lets you animate view changes without having to write a single declare. And it's going to be available on GitHub later today. Oh, there's one more thing. My library also allows you to work with auto layout on Xojo macOS desktop projects. The process for using auto layout on macOS is pretty easy. You lay out your windows using the Xojo layout editor as you did before. In the opening event, you convert the layout to auto layout with a single call, and then you override the behavior using the SOS layout constraints and the SOS layout anchors. Here are some great things that are possible using auto layout. You can decide at runtime whether a window or container will use auto layout or not. So not all the windows need to use auto layout. You can get true baseline alignment. The Xojo IDE guesses, but Apple's changed the control heights and the baseline offsets over the years. Intrinsic control sizing based on content for controls that support it. And true left to right language support on systems that use right to left languages, leading and trailing anchors and constraints flip automatically. And here's some challenges that I ran into. Window min and max size are converted to constraints, so they also respond to the constraints of the controls on them. You may not get the exact window size you asked for in Xojo if the constraints on the view change that requirement. Radio groups. For most of the Xojo controls, it was pretty easy to reach inside them and add the constraints as necessary to make them just work. But unfortunately, desktop radio group was not. If you decide to use radio groups in your macOS projects, you will need to support, and you need to support right to left languages. You'll need to use the old mechanism of putting a series of radio button controls into another container. Okay, I want to show you guys a little bit of the constraint code that I wrote. Oops, there we go. All right, so what I'm going to do here is I'm going to do a pretty simple example in the iOS thing. I'm going to put in a label and text field. Now the goal here is, let's see if I can put some stuff here. The goal here is to have the label and the text field aligned within the system distance from one another, and for the baselines to line up. And I'm going to do something with the intrinsic content size as well. So we're going to say okay, so I'm going to do this work in the opening event screen. Come on. So the first thing that I'm going to do on this layout is I'm actually going to convert. I'm going to copy this whole thing. We're going to call a method that converts all the constraints for all the controls to the SOS layout constraints and sets their priority to 900. And the reason that we're going to do this is that this way I don't have to go through and remove the Xojo created constraints. They'll all just get pushed down in priority. So they'll still be used if auto layout can't use the ones I'm going to put in. And if I run that, you'll see that nothing's really changed. It's pretty much exactly the way it was before. So just running that shouldn't actually change your layout a whole lot. Now, the next piece we're going to do is we're going to make the label match its intrinsic size. We're going to create a new SOS layout constraint. We're going to ask for a constraint matching its intrinsic width so that it's priority not to 999 and true. As I mentioned during the presentation, the reason I'm using 999 here instead of 1,000 is that once you set a constraint to 1,000, you cannot change its priority later. If you set it to 999, you can. So if I run this again, you'll notice that it doesn't actually work. We would expect this label to get really long. And the reason that that doesn't change is that Xojo's label control is multi-line by default. So what I'm going to do is I'm going to add a line above here. And whoops, should we comment that? So this is a method extension that's part of the control extensions that I provide that allows you to actually tell a label how many lines it's going to be. We're going to tell it just one. And you'll see that as soon as we do that, it now knows that the intrinsic size is correct. Okay. So now what we're going to do is we're going to create a second constraint to align the baselines. We're creating a constraint between the text field 1 and text field 2, and label 1 based on first baseline. This is another extension method I created for creating constraints when you know that it's just two controls and a particular attribute. The offset for a text field when dealing with just a generic text field has to be changed. And part of the reason for this is that the text field has this buffer space above it and below it. So you need to actually adjust the offset a little bit. And then again, the priority, and we're going to set it active. And if we run this, now the two items are perfectly aligned on their baseline. Now we're going to tell it that we want. We're going to create another constraint. This one uses an anchor. So we're going to set text field 1's leading anchor equal to the system spacing after the trailing anchor of label 1. And this will separate them. It'll run. So now we have that system spacing in here. Now what I'm going to do is I'm going to constrain these, add more anchors, such that label 1's leading anchor is constrained to the view's leading anchor, the system spacing. And I'm going to constrain the trailing edge of the text field against, so again, constraining from items on the right to ones on the left. This is the trailing edge of the view constrained against the trailing edge of the text field. So if I run that, now we've got system spacing here, unexpectedly long label, system spacing here. And we didn't even have to define the width of this thing. It's just getting it correct. There is one problem though. I'm going to rotate this and you'll notice, well, let's rotate it the other way. It'll be easier to see. Now the label goes under the dynamic island. This is what I was talking about earlier, where Xojo doesn't understand. If I had constrained this to the left, Xojo doesn't have an understanding of where the dynamic island is. So we can actually go back in now with the constraints and we can tell it the view actually has a safe area layout guide. We can do that. We can put another one here. Oops. When I run it again, now it will avoid those areas, no matter which way it's oriented. Now, I've got a demo project that is included in the GitHub repo. Grab, I think it's that one. And you guys got to see that I've been playing with Minecraft for my nephew. Let me run this real quick. So this is an example of the animation framework that I added. So if I just click toggle constraint, the text field and this button actually just flip between the two positions. If I click animate, it actually does a slight animation between the two. And you can use that if you're going to change constraints between a horizontal and a vertical layout, if you want things to actually kind of slide to where they need to be. This is an example where we're going from the Xojo constraints to a view with anchors, which also just slides things around. Let's see, this one is all about hugging and compression. And I was noting earlier about how as priorities change, that hugging and compression can come into play. And you can see it as I slide this slider, it's changing the priority of the constraints that are being applied to the 6 items at the top. And what's happening here, when you have it at 999, it's using it's getting to use all the constraints that were supplied. But as we reduce that number, some of them are being ignored because the higher constraints actually provide enough information, at least as far as iOS is concerned, to make a layout. And when you get down really low, I was talking about how the compression stuff works. When we get down to 250, things get really wonky. That flipping is what iOS calls an ambiguous layout, right? So there are 2 possible solutions, and it's just flipping between them as I slide the slider here. The other thing that this layout shows is how auto layout can help you with localization. Now, I translated these in Google Translate, so they may be wrong, but anyway, you can see as I click this, these are all being done on the fly. So we're pulling the new localized values out of a localized constraint in Xojo, and then asking iOS to pull a new intrinsic content size for each one of these items so that they can be sized properly. Normally, you would just do it up front, and if you do it in the opening event, it can just do the resizing for you, and then you don't have to go through all the math. But in this project, it shows how to do the math and how to pull different languages out at runtime. This is an example of a stack view. And it changed sizes on me again. But anyway, this is a stack view where each one of these is a container that's in a rolling area here. Let's see if I fix that. Then we have to file a bug report with Xojo about that. And it's not there. All right. And I don't remember what that before. I think this is an example of having a bunch of labels and a bunch of fields and doing the math so that all of these will be equal in size and that sort of stuff. All right, let me bring up. Yeah. Now, in the case of Mac, what I'm going to do is this is a layout that I did in Xojo. It doesn't have any constraints applied to it right now. So if I just run this the way it is, oops, it would help if it put it over here. And you'll see that this label, it's supposed to say municipality, but it got cut off because it's too long. And like a traditional macOS app, you know, if you make it too small, it'll truncate all the controls and all that stuff. It's so common to see users who have forgotten to set the minimum size, for instance. And you get, users are able to do that. So anyway, what I'm going to do is in the opening event, I'm going to start adding some controls or some constraints. Okay. So the first thing I'm going to do here is I'm going to convert this window to auto layout. And the two parameters are whether or not to use leading and trailing, and whether or not to unconstrain the window. So the library will give you the option of whether you're going to use left and right or leading and trailing for all the constraints it creates, and whether or not you want the window to be able to resize independently. I don't know if that second one's actually working yet, but anyway. So if I just run this, it's going to keep putting it on the other window for me. All right. So I just run this, we get an immediate fix for this, and that is the window can't get any smaller than this. The container has some constraints on it that tell it what the minimum size is. So that actually prevents us from getting too small. And then the other controls on the layout, because they have width to them, actually prevent the window from getting any smaller now. Like on iOS, you can tell it to convert the constraints with particular priorities. We're actually going to do them all as required in this case by default. And then let's see. Now, I'm going to tell the container that it should be less than or equal to 600. And when I run this now, this container is still preventing us from getting smaller. I don't think that changed. All right. I'm going to tell the city label and the buttons. Actually, this is this label and this button to use intrinsic width. And when we do that, we can't see it yet because it's going under there, but this button now automatically resized to its containing text. This isn't going to be much of a change because I made a extension method for aligning controls to labels, so it will just create the constraint for you between a control and a label. It makes setting these things up a lot easier. And then we're going to tell the bottom of the view to always be the system spacing from the bottom of the text area. So now there's a constraint here between this text area and the bottom of the view. Okay, getting there. Now I'm going to tell it that I want the text area to not get any smaller than the design time size. So the size that it's in the layout editor, this size, is now going to become the minimum size for that thing. And now we get a drastic change, because now the window can get bigger, but it can't get any smaller than this because auto layout is requiring this text field to at a minimum size be this size. We can also tell it this, the text area can't be wider than 300. Now it'll stop when it gets to 300 wide. Now you'll notice that we still have this problem with municipality. What we're going to do is, this is partially caused by all these constraints being set to 1000 up here. So what we're going to do is I'm going to change the constraint priority just for that control. Make sure I get this in the right place. So we're going to, after converting all the constraints or all the controls to 1000, we're going to do just city field to 751. It's just above that compression resistance stuff. And then we're going to add a constraint between the city field's right anchor and the container's right anchor. And the reason there were, whoops, if it's actually true. The reason, let me see. And the reason we're doing that is so that these two edges align properly. Because when this gets wider, this whole city label got moved over. So now we have a constrained view. It can't get any bigger than that, can't get any smaller than that, and everything is being driven by constraints. Okay. Do we have any other questions?
Looking at the QA panel, it doesn't look like there are any questions.
C2. Nope. Okay. Well, I'm going to go on to GitHub in 10 minutes or so, and I will make sure that that project is, well, let me go back because I've got that.
It looks like Bob's got a question. Bob, if you could put it in the Q&A panel, then we can get to it. So if anyone has any questions, again, put them in the Q&A panel. Okay, do you see it, Greg?
Yeah.
Bob's question.
I thought, Bob said, I thought I saw that iOS stuff was going to use the same technique as Android in an upcoming release. Yeah, so I actually talked to, let me answer live here. I talked to Xojo actually right about the time that they were doing XDC this year. And what they told me was that the goal is to move to the locking system that, or at least make the locking system that is used on Android and on desktop and such for iOS as well. But keeping in mind that iOS under the hood still uses constraints. So Xojo can't really get rid of it. If Xojo removes the ability to use constraints altogether, then we'll alter this project so that you can still convert everything.
Yeah, just to be clear on that, just to clear that up a little bit. So the plan is to go to locking and to keep the ability to add constraints in code. So we're not going to get rid of constraints. And Greg is right that essentially the locking system has to be built on top of constraints. And there are some things which we're not prepared to talk about yet that we're going to do to the locking system to make it more powerful as well. So so the idea is to simplify the whole thing, but also leave the constraint system in place for people that need it. Okay, It doesn't look like we have any more questions. Greg, thanks so much for being here and putting this on. It was extremely informative. Even I learned a lot, actually, and I felt like I knew a lot about constraints, but I learned something from this webinar. So I really appreciate you putting in the effort.
Yeah. And I will post the link for the GitHub repo on the forum as well as soon as I get it. It's there. It's just marked private, so I just need to unmark it. But I'll post something on the forum when it's
And
ready.
Greg, send me an email and I will add it to the third-party page in the documentation as well.
I will do that.
Great.
Thanks, everybody.
Yep. Thanks. Until next time.
Yep.
Bye-bye.